हेलो स्टूडेंट्स, सो टेस्ट 78 का डिस्कशन स्टार्ट करते हैं। अभी तक जितने भी पेपर्स हम लोगों ने सॉल्व किए हैं, ये इनमें सबसे ज़्यादा डिफिकल्ट पेपर है। आई डोंट थिंक किसी भी पर्सपेक्टिव से ये नीट के लिए अप्रोप्रिएट पेपर है। आप सॉल्व करने के बाद बिल्कुल भी डिस्करेज नहीं हो। हाँ, इट इज़ अ लेसन कि कभी भी इस तरह का डिफिकल्ट क्वेश्चन आ जाए तो आप अपना कंपोजर मेंटेन रखें, अपने आप को कंपोज रखें, अपनी दिमाग की शांति बनाए रखें और जितने क्वेश्चंस आपसे हो रहे हैं उनको अच्छी तरह से करें, क्योंकि मोस्टली स्टूडेंट्स एक्चुअली डिफिकल्ट पेपर में गड़बड़ करके जो उनसे क्वेश्चंस हो रहे होते हैं वो भी सॉल्व नहीं कर पाते हैं। तो अपने को इस चीज़ का ध्यान रखना है। दिस इज़ अ लेसन फॉर अस कि जितना हो रहा है अपने से उतना अपन अच्छी तरह से करें। तो स्टार्ट करते हैं क्वेश्चन। मतलब मैंने जो पहले लिखा है अराउंड 18 क्वेश्चंस को मैंने डिफिकल्ट की कैटेगरी में डाला है, जिसमें एक क्वेश्चन तो मैं कहूँगा आउट ऑफ सिलेबस ही थ्योरी से है, उसको अपने को टच करने की जरूरत नहीं है। 12 क्वेश्चंस मीडियम डिफिकल्टी लेवल एंड 15 क्वेश्चंस इजी क्वेश्चंस की कैटेगरी में रखे हैं मैंने। ओवरऑल 100+ स्कोर इज अ गुड स्कोर मैं बोलूँगा। तो क्वेश्चन नंबर 1 से अपन स्टार्ट करते हैं। द इलेक्ट्रिक पोटेंशियल इज दिस अज्यूमिंग बोर्ड मॉडल टू बी वैलिड। तो IIT में आया हुआ क्वेश्चन है ये। हम पहले इलेक्ट्रिक पोटेंशियल से फोर्स निकाल लेंगे। सो फोर्स इज माइनस dV/dr, सो दैट इज V0/r, दिस इज फोर्स। और इसको ये रिक्वायर्ड सेंटीमीटर फोर्स प्रोवाइड कर रहा है। सो दिस इज इक्वल टू mv²/r। तो फोर्स का मैग्नीट्यूड है V0/r एंड दिस इज इक्वल टू mv²/r। तो यहाँ से r कैंसिल हो रहा है, तो v हमारा कांस्टेंट आ रहा है। नाउ mvr इज nh/2 and v is independent of r, so r is proportional to n. So A is the correct option. The work function of metal A is equal to the ionization energy. The work function of metal A is equal to the ionization energy, okay, of the hydrogen atom in the first excited state. And so first excited state, so 3.4. So phi A is 3.4 eV. The work function of metal B is equal to the ionization energy of helium plus ion in the second orbit. So ionization energy in the second orbit of helium is 2 square into 3.4, which is 13.6 eV. Okay, now photons of the same energy E are incident in both A and B. The maximum kinetic energy of photoelectrons emitted from A, so E minus 3.4, this is maximum kinetic energy emitted from A, is twice that of the photoelectrons emitted from B. So twice E minus maximum kinetic energy of photoelectrons emitted from A is twice that of photoelectrons emitted from B. So E minus 13.6, twice of that of, okay. So E equals 27.2 minus 3.4, which is 23.8 eV. So A is the correct option. The coordinates of the center of mass of uniform flag shaped lamina. So guys, let's divide it into two parts. First part is this, okay. Area is 2 is width and 1 is height, okay. So area is 2 meters square and center of mass coordinates C2 are height, the top point has height 3 and the bottom point has height 2, so 3 plus 2 divided by 2, 2.5. And x coordinates of extreme 0 and 2, so 1, so 1 comma 2.5 meter. This is coordinates of center of mass of this portion, and for this portion height is 2, base is 1, so area is 2 meters square and center of mass coordinates are 0.5 comma 1 meter. So now xcm, see both the parts have same area, so they have same mass. So xcm m into 0.5 plus m into 1 upon 2m, so that is 0.75 meter. And similarly ycm m into 1 plus m into 2.5 upon 2m, that is 1.75 meter, okay. So xcm ycm we have calculated, so 0.75 and 1.75 meter. Now next fourth question. The masses of 5 balls at rest and lying at equal distances in each straight lines are in geometrical progressions with ratio 2 and the coefficient of restitution are each 2 by 3. If the first ball is started towards the second ball with speed u, then the velocity communicated. Okay, so let's say first ball has mass m and it starts moving with speed u. Second ball has mass 2m. Okay, so applying momentum conservation equation, mv1 plus 2m v2 is equal to m into u, and then velocity of approach is equal to velocity of separation. So v2 minus v1, for inelastic collision velocity of separation is e times velocity of approach, so eu minus 0. All right, so m cancels. Let's add these two equations. So 3v2, e is given 2 by 3, so 2 by 3 u. So 3v2 is 5 by 3 u, so v2 is 5 by 9 u. So after first collision, velocity becomes 5 by 9 u. After second collision, velocity becomes 5 by 9 times v2, which is 5 by 9 whole square into u. So after fourth collision, first and second particle में first collision, second third में second collision, third fourth में third collision, and fourth fifth में fourth collision. So after fourth collision, है ना, velocity of the fifth particle will be 5 by 9 raised to power 4 into u. So D is the correct option. A simple pendulum is oscillating. The direction of acceleration of the bob is horizontal at a point. So initially pendulum is horizontal and this is the lowest position. Okay, at intermediate point, say at an angle theta from vertical, acceleration is horizontal. So here in this direction there is centripetal acceleration v square by L, and in this direction there is tangential acceleration g sine theta. This angle is theta, so net acceleration is horizontal. So this is net acceleration a net. Okay, now this angle is theta. All right, so tan theta is v square by L upon g sine theta. V square from energy conservation is u square plus 2gh. U square is 0 and 2g, h is L cos theta. The block has descended L cos theta. So v square is u square plus 2gh. So 2gl cos theta upon gl sine theta. So this manner we get tan theta equals root 2. So cos theta is base upon hypotenuse. Base is 1. Hypotenuse is root 2 ka square plus 1 ka square, the under root. So that is root 3. So theta is cos inverse 1 by root 3. A disk of radius r is spun to an angular velocity omega. Its axis then imparted a horizontal velocity. So horizontal velocity is not mentioned in the question. From solution I saw that the horizontal velocity is omega naught r by 4. So question is incomplete actually. The horizontal velocity omega naught r by 4 of magnitude with its plane remaining vertical. The coefficient of friction between the disk and the plane is mu, the sense of rotation. So choose the correct statement. So the disk will start rolling in the slip without slipping in the direction of v naught. It will never be slipping will never be ceased. So guys, initially the disk is slipping and velocity is towards right and angular velocity is in anti-clockwise sense. So in this kind of problem, angular momentum about the initial point of contact remains conserved. So you calculate initial angular momentum about the point of contact, L about A. So angular momentum about CM, angular momentum about A is angular momentum about CM, L dash, plus angular momentum of CM about the given axis. Okay, so first term is ICM omega and second term is m r of cm with respect to a cross vcm. Okay, so LA initial we see ICM omega, so that is mr square by 2 into omega naught, and in anti-clockwise sense we have taken negative, and L of cm about a is m v naught, which is omega naught r by 4 into r. So the total angular momentum is negative. So LA initial in anti-clockwise sense, which means finally the body will roll towards left. So first the translational velocity will become 0, and due to friction it will start moving towards left. So disk will return to the initial point. Slipping will never be ceased. If initial angular momentum would have come 0, then the slipping would have ceased. But initial angular momentum is non-zero. It is in anti-clockwise sense. That indicates that the body will going to roll towards left. If this initial angular momentum would have been positive, that means the body will roll towards right. So this is an important question to learn. The resistors P and Q are connected in the pages, connected in the gaps of the meter bridge. The balancing point is obtained 1/3 meter from the 0. So P by Q is 1/3 upon 2/3, that is 1/2. This is equation 1. Now if 6 ohm resistance connected in series with P, so P plus Q upon Q, the balance point shifts 2/3 meter. So 2/3 upon 1/3, that is 2. This is second equation. So from first equation, P equals 2P equals Q, and second equation, P plus Q equals P plus 6, sorry, I have written wrong. This is 6. P plus 6 is equal to 2Q. Now Q is 2P, so P plus 6 is equal to 2 into 2P. So P equals 2 ohm, and so Q equals 4 ohm. So 2, 4 is the correct option. Which of the following statements is false? Kirchhoff's second law represents energy conservation. Yes, this is based upon conservative nature of electric field. Wheatstone bridge is the most sensitive in all the 4 resistances are of the same order of magnitude. This is also correct. In a balanced Wheatstone bridge, if the cell and the galvanometer are exchanged, the null point is disturbed. This is false statement. A current of 10 ampere in the primary coil of circuit reduced to 0. If the coefficient of mutual inductance this, EMF induced is this, then time taken for change of current. So guys, M delta I by delta T mod is equal to induced EMF. So delta T is M mod delta I upon E. So M is 3 Henry, delta I is 10 ampere, and E is 30 kilovolt, 10 to the power 3. So this comes out to be 1 millisecond, 10 to the power minus 3 seconds. So C is the correct option. Transformer is having this NS and NP NS, and an AC source of this is connected to primary, the secondary voltage. So Vs upon Vp is Ns upon Np, so which is twice. So Vs is twice of Vp, that is 240 volt, and Vp IP is equal to Vs Is. So Vs is 2 times Vp, so Is is Ip by 2, that is 5 ampere. So 245 is the correct option. Two large conducting plates Q, 3Q respective. The electric field in the region between the plates is E0. Then the force of interaction between them. So force is field of one plate, electric field of one plate multiplied by charge on another plate. Okay. So electric field of left plate on the position of right plate is Q upon 2A epsilon naught multiplied by charge on the plate, which is 3Q. So this is 3Q square upon 2A epsilon naught. Now the electric field in the region between the plates, left plate has electric field towards right, right plate has electric field towards left. So net electric field in the region between the plates is 3Q upon 2A epsilon naught minus Q upon 2A epsilon naught, that is Q upon A epsilon naught. So substitute Q equals A epsilon naught E, Q upon A epsilon naught equals E in the force expression. So 3Q by 2 and Q upon A epsilon naught E. So 3Q E upon 2. So C is the correct option. A solid ball, the electric field outside the ball. So electric field outside the ball is 1 by 4 pi epsilon naught into Q enclosed, which is 4 pi x squared dx, into charge density, which is rho naught 1 minus x by capital R, integration from 0 to capital R upon small r square, kq enclosed upon small r square. So 4 pi cancel, rho naught epsilon naught r square x square dx integration x cube by 3 and x cube by r integration x4 by 4r, limits from 0 to capital R. So that is rho naught r cube upon 12 epsilon naught r square. So D is the correct option. The gravitational field at the center of the hole. So gravitational field at the center of the hole, this O, electric field due to the remaining sphere is gravitational field due to the complete sphere minus gravitational field due to the cavity, assuming it to be filled with same mass density. So gravitational field due to the complete sphere at r by 2 from center is gm r by 2 upon capital R cube, and E due to the cutout, assuming it to be filled with same mass density at the center, gravitational field due to the cutout will be 0. So complete field will be gm by 2 r square. So C is the correct option. At what height in kilometer over the Earth's pole the free fall acceleration decreases by 1%? So delta g by g is minus 2h by r. So that is minus 1 by 100. So h is r by 200, that is 6400 upon 200, that is 32 kilometer. So A is the correct option. The maximum wavelength of radiation at 2000 Kelvin is 4 micrometer. What will be maximum wavelength at 2400? So lambda 1 T1 is equal to lambda 2 T2 according to the Wien's law. So lambda 2 is lambda 1, which is 4 micrometer, into T1, which is 2000, upon T2, which is 2400. Okay, 2400. So 5, 6, 2, 3. So 10 by 3, which is 3.3 micrometer. Air is filled in a bottle at atmospheric pressure and it is cocked at 35 degrees C. If the cork can open out a pressure of 3 times the atmospheric pressure. So initially P initial is P naught and we want P final to be 3 P naught and volume is constant. Okay, so P final upon P initial is T final upon T initial. So that is 3. So T final is 3 times T initial, that is 3 times 273 plus 35. So 273 plus 35, 538, 73, 10, 0, 308 into 3, that is 924 Kelvin. So T final in degree Celsius is 924 minus 273. So that is 112.5 and then 8 to 6. So 651 degrees Celsius. So correct option is 651 degrees Celsius. C is the correct option. Alright, now let's move to the next question. 17th question. 1 mole of an ideal gas at temperature T1, find the work done. So given that P by V is constant, let it be K. So P is kV. So work done is P dV integration, which is kV dV integration from V1 to V2, that is K V square by 2 integration from V1 to V2, that is K V2 square minus V1 square by 2. Now KV2 is KV is P. So KV2 is P2. So this is P2 V2. KV1 is P1. So P1 V1 upon 2. PV equals nRT and number 1 mole. So RT. So R T2 minus T1 upon 2. Another method, alternately, we can go by polytropic process. We know that C is CV plus R upon 1 minus X. So this part represents delta U and this part represents W. So W is R upon 1 minus X into delta T. R upon 1 minus X is minus 1, P to the minus 1 equals constant, X is minus 1 into delta T, T2 minus T1. So this is R T2 minus T1 upon 2. This is alternate method. Two particles of masses MA, MB of same charge projected in perpendicular magnetic field, circular paths, RA greater than RB. So RA greater than RB, that means same charge. So MAVA upon QB is greater than MBVB upon QB. So MAVA greater than MBVB. Two north poles of each of pole strength M and a south pole of pole strength M are placed at the three corners of an equilateral triangle. So treat pole strength M as charge plus Q and south pole as charge minus Q. So this is plus M, this is plus M, and this is minus M. And field due to a single pole is mu naught by 4 pi M into M by R square. So magnetic field at the center due to the topmost pole is downward B. All the three will produce same magnetic field of same magnitude. Due to this, magnetic field is in this direction, and due to this, the magnetic field is in this direction. Okay, so this angle is 120 degree. Okay, so B1 and B3, B1, B2 and B3. So B1 and B2 have resultant along B3. All are of same magnitude. So B net is twice of B1 cos 120 by 2 plus B. All three have same magnitude. So twice of B cos 120 by 2 plus B, that is 2B, that is 2 mu naught by 4 pi M, and distance of center from the vertex is A by root 3. So A by root 3 ka square. So that is 3 mu naught M upon 2 pi A square. 3 mu naught M upon 2 pi A square. B is the correct option. A bar magnet of A is cut axially into two equal parts. So this is cut lengthwise axially into two equal parts. Okay, if these two pieces are arranged perpendicular to each other, so magnetic moment is of the complete bar is M1. So the magnetic moment of one portion will be M1 by 2. So this is M1 by 2 and this is M1 by 2, M1 by 2, M1 by 2. So resultant magnetic moment of the second system is root 2 M1 by 2. So we need to find out M1 upon M2. So that is root 2. So D is the correct option. Velocity V versus X plot is given and acceleration versus X. So acceleration is V dV by dx. Guys, for V is linear function and dV by dx is constant for 0 to 100. Okay, so acceleration at V is linear function of X, and dV by dx is constant. So acceleration will be linear function of X. For X between 0 to 100, acceleration is positive. V is increasing, dV by dx is constant, so acceleration is positive and increasing linearly. For X between 100 to 200, acceleration will become negative since slope will become negative. Okay, acceleration will become negative and V is decreasing, dV by dx is constant, so magnitude of acceleration will decrease. So correct graph will be first acceleration is positive, increasing linearly. At 100, the polarity, the sign of acceleration changes because dV by dx changes in magnitude and dV by dx changes in sign, and then from 100 to 200, acceleration is decreasing in magnitude. At 200, dV is 0, so acceleration is 0. So correct option is C only. Okay, or we can check, see at x equals 0 and at x equals 200, at both positions V is 0, so acceleration is 0. So at 0 and 200, acceleration is 0, that is only in the graph C. So C is the correct option. A boy standing on an open truck, the truck is moving with acceleration 2 meters per second square on a horizontal road. When the speed of truck is this, reaches to an electric pole. So electric pole is a fixed position on the ground. Electric pole. Boy projected a ball with velocity this in vertically upward direction relative to himself. Neglect the height of the boy and truck, the distance of the ball from the pole where the ball land. So we are to calculate range in the frame of ground. Okay, so this is the railroad car, this is the open truck, boy is standing at this position and he throws the ball, u of ball relative to truck in this direction. Truck is moving in this direction, acceleration of truck is in this direction, and at this position there is a pole. So this is pole. Okay, so this is fixed position relative to ground. So acceleration, so initial velocity of ball relative to ground is velocity of ball relative to truck plus velocity of truck relative to ground. So that is 10 j cap plus 10 I cap. Let's consider this to be x direction and this to be y direction. And acceleration of ball relative to ground is g downwards, so g minus j cap. This is acceleration. Now the ball has horizontal component 10, vertical component 10 velocity components, and acceleration is 10 downwards. So in the ground frame, range is delta x of ball relative to ground is 2 ubx uby upon g. So that is 2 into 10 into 10 upon 10. So the ball falls 20 meter ahead of the electric pole, 20 meters. So A is the correct option. If the coefficient of friction between the wedge A and block B shown in figure is mu, then the maximum possible horizontal acceleration of A for which B doesn't slip. Okay, so this wedge is being moved towards right. Okay, so in the frame of wedge we are going to solve the problem. Pseudo force will act towards left, MA, mg downwards, normal reaction, normal to the plane, and this angle is theta and this angle is also theta. So driving force is ma cos theta minus mg sin theta. This is the net force acting in upward direction, which is trying to move the block up. Okay, and this is being balanced by limiting friction in the limiting equilibrium. So this is mu n, and n is mg cos theta plus ma sin theta. As theta is 45 degree, so cos theta sin theta cancel, m also cancel. So a 1 minus mu is g 1 plus mu, so a is g 1 plus mu upon 1 minus mu. So all these questions are difficult questions for NEET. Two blocks each of mass m are joined together using an ideal spring, natural length L0. The blocks are touching each other. So initially both the blocks are touching each other. That means the length of the spring is 0. That means initial deformation is L0. And now when the extension of the spring is L0 by 4 and x initial is minus L0 and x final is L0 by 4. Extension is L0 by 4, initially compression L0 and finally extension L0 by 4. Both the blocks come to rest. So let's apply energy conservation, energy change, mechanical energy change equation. W friction barabar delta U plus delta K. So both the blocks have collectively moved 5 L0 by 4. So work done by friction is minus mu mg into 5 L0 by 4. Okay, and delta U half K L0 by 4 ka square minus half K L0 square. So this is 5 mu mg L0 by 4 minus sign, and this is half K L square by 16 minus L square, so minus 15 L square by 16, minus signs cancels, and 5 3s are 15, so and 2 2s are, there's 2 8s are, so this is 3 by 8, so 3 KL0 mu is 3 KL0 upon 8 mg. C is the correct option. In the option given below, let E denote the rest mass energy of nucleus and N a neutron. So this is a fission reaction. A heavy nuclei is dividing into lighter nuclei. So rest mass energy of parent nucleus should be greater. Mass should convert into energy. Okay, rest mass energy of parent nucleus should be greater. So A is the correct option, because in A, rest mass energy of parent nucleus is greater than that of the daughter nucleides. Okay. So which is the feasible reaction? So this is binding energy per nucleon. Okay, in a first case, A plus B goes to C plus E. Binding energy of the product is greater than the binding energy of reactant. In the first case, when you calculate the sum of binding energy of A plus binding energy of B, that will be less than binding energy of C. So A is correct option. And similarly, binding energy of F, binding energy of F is A plus B. Binding energy of A plus B is lesser than that of C in A option. And similarly, binding energy of F is also lesser than binding energy of D plus E. All right. So according to me, A and D both are feasible options. A coin is placed on a horizontal platform. So platform is executing horizontal SHM. So to the coin, friction is providing the required centripetal force. Suppose this is x is equal 0. So frictional force is providing the required acceleration, not centripetal force, required acceleration ma, which is minus m omega square x. So maximum friction is required when the block is at the extreme position, coin is at the extreme position. So the maximum requirement of friction is m omega square capital A, and when it is equal to mu s mg, the coin will tend to slip. So A is mu g upon omega square for an amplitude of mu g upon omega square. An object of mass m executes SHM at the position x equal, the object has kinetic energy. So omega is 2 pi f, that is 4 second inverse. This is omega. And kinetic energy, so k is half m omega square a square minus x square. Kinetic energy is 24 joule. Half m is 1, omega square is 16, a square minus x square, which is 1. So this is a equals 2 meters. So B is the correct option. Light of wavelength lambda 1 and lambda 2 are incident on a metal surface, and if the ratio of the maximum speed of the electrons ejected is 2, the work function of the metal is. So guys, K1 max upon K2 max, which is hc by lambda 1 minus phi upon hc by lambda 2 minus phi. Maximum speed ratio is 2:1, so maximum kinetic energy ratio will be 4:1. So this is 4:1. Okay, so hc by lambda 1 minus phi is 4 times hc by lambda 2 minus 4 phi. So 3 phi is equal to hc 4 by lambda 2 minus 1 by lambda 1. So phi equals hc by 3 4 by lambda 2 minus 1 by lambda 1. So hc is 1240 upon 3, and 4 by lambda 2. Lambda 2 is given 540 and lambda 1 is given 1 by 340. Okay, so this is 124 by 3, 2 by 27 minus 1 by 34. So this is 124 into 68 minus 27, which is 41, and upon 3 into 27 into 34 in electron volts. Okay, so 27 34. Okay, 3 9s are 27, 3 4s are 12, 3 1s are, so this is this 9. Now 3 4s are, this is approximately 14. All right, and 7 2s are 14, 7 5s are 35. Approximations we are doing. So 41 by 35, 5 8s are 8 by 9. So this is roughly we are calculating 41 2s are 82, 82 upon 35, 82 upon 30. No, it's just a minute. So let's do it once again. I have just missed. So this is 34 to the 68, 68 minus 27, which is 41. So 124 into 41 upon 3 into 27 into 34. Okay, so 4 3s are 12, 4, so 3 4s are 12 and 3 1s are, so this is approximately 41. so 41 into 41 and नीचे 27 है, तो 9 4s are 36. Okay, so now let's 41 into this, and this is so 41 ones are 3, let's do it 14. Okay, so 14 ones are 14 4 and 1 14 fours are 56, 57 upon 9 fours are 36, 6 3, 9 threes are 27, 3 303. So 1306 upon 574 upon 306. So this is definitely greater than 1.5 and lesser than 2. So the correct option is 1.85 electron volts. The potential difference that must be applied to stop the fastest photoelectron emitted by a nickel surface. So EVS is, just a minute, EVS is Hc by lambda minus 5. So EVS is Hc, which is 1240 nanometer electron volt upon 200 minus 5, 5.01. So EVS is 6.20 minus 5.01. So that is 1.19 electron volt. So VS is 1.2 volt. So D is the correct option, 1.2 volts. The potential difference that must be applied to stop the fastest photoelectron emitted by a nickel surface having work function this. So if you go by polarity, then it should be minus 1.2. I mean, the figure is not given. So stopping potential is 1.2 and just potential difference, then it should be minus 1.2. The two liquid drops have diameters of 1 in this. The ratio of axis pressure, so delta P is 2s by r. So delta P1 upon delta P2 is R2 upon R1, which is D2 upon D1. So that is 1.5 upon 1, that is 3 by 2. So D is the correct option. A rod of length and radius r is joined to a rod of length L by 2 and radius radius is not given. What is the radius of the second rod? Same material, the free end this, the twist angle at the joint. So this theory is beyond our syllabus. I would advise you to leave this question, and the question is incomplete as well. Concave lens is in contact with concave lens, the magnitude of the ratio of their focal lengths. So F1 is positive and F2 is negative. So magnitude ratio is F minus F1 by F2. Actually F1 is positive and F2 is negative. So negative negative is positive. This ratio is given 2 by 3. So we have 3f1 equals minus 2f2. This is first equation. And second, the equivalent focal length. So 1 upon f1 plus 1 upon f2. This is given 1 by 30. So 1 upon f1, f2 is minus 3f1 by 2. Minus 3f1 by 2 is equal to 1 by 30. So that is 3 minus 2, 1 by 3f1 is equal to 1 by 30. So f1 is 10 centimeter. And f2 is 30 upon 2 minus 15 centimeter. So minus 15 comma 10, this is the correct option. 34th, light undergoes internal reflection, triangular prism for alpha minimum. So just a minute. So alpha minimum, है ना? So this is the triangular prism. Light is incident from above at an angle alpha. It will go at angle R and will be incident at an angle R dash on the second surface. So from geometry, this is 90 plus R. And this is 90 minus r dash, this is theta. So 90 plus r plus 90 degree minus r dash plus theta is equal to 180 degree. So r minus r dash plus theta is equal to 0 degree. So r dash is r plus theta, r dash is r plus theta, okay, or r dash minus r is theta. So r dash is r plus theta. So when incident angle is minimum, this r is minimum, so r dash is also minimum, and the ray is going TIR. That means r dash is equal to critical angle theta c. Now what is critical angle? Sine theta c is 1 upon n, that is 1 by root 2. So theta c is 45 degree. Okay, so r dash is 45 degree, and applying Snell's law between at the first surface, 1 into sine 45 degree is equal to root 2 into sine r. So r is 30 degree and r dash is 45 degree. Now 45 degree is equal to 30 degree plus theta, so theta is 15 degree. So this is a difficult question for NEET. If moment of inertia of the solid sphere about its geometric axis and for the disk about the shown axis is same, so for the solid sphere 2 by 5 mr square, for the disk this is mr square, m capital R square. For the disk it is mr square by 2 plus mr square. So 2 by 5 capital R square is equal to 3 by 2 r square. So small r is 2 by root 15 capital R. A disk is rotated about its axis with a certain angular velocity and lowered gently. So initially v is 0 and omega is non-zero. The point of contact is slipping towards left, so kinetic friction will act towards left. So that is mu k n, which is mu k mg cos theta, okay, and mg sin theta will act downward direction. So mg sin theta minus mu k mg cos theta is equal to mass times acceleration of center of mass. Now since mu k is 1 by root 3, so this is mg half minus 1 by root 3 into root 3 by 2 is equal to m ACM. So ACM is 0. We could have said this directly, tan theta equals mu. So this is angle of repose. The acceleration, linear acceleration will be 0. ACM is 0. Alright. So initially linear acceleration will be 0. So center of mass of the disk will remain at that position only, and the angular speed of disk will keep on decreasing till it comes to at rest, and then the disk will roll down. So it will rotate at the position where it was placed and then will move downwards. Yes. So A is the correct option. So this is also a difficult question. In the figure, potential difference between A and B. So we are observing that the diode is in forward biased. So in that case, the equivalent resistance is 15 kilo ohm. So current 15 kilo ohm. So these two resistances are 20 kilo ohm. So potential difference across AB is 20 upon 20 plus 10 into 30, that is 20 volt. Okay, sorry, this is 5. I made mistake. They are in parallel, so this is 5 kilo ohm. So 5 upon 5 plus 10 into 30, that is 10 volt. So potential difference across AB is 10 volt. Combination of gates हम solve कर सकते हैं आराम से. Monoatomic gas is suddenly compressed to 1/8 of its initial volume. So P dash is P V upon V dash raised to power gamma. So P V upon V dash is V by 8, gamma 5 by 3. So that is 8 raised to power 5 by 3, which is 2 raised to power 5, which is 32 P. So final pressure is 32 times initial pressure. Unit of magnetic moment, ampere meter square, NIA. So ampere meter square. In Young's double slit experiment, D is this, capital D is lambda is the angular position of first dark fringe. So theta is 2n minus 1 lambda by 2 small d. So first, so lambda is 5460 into 10 to power minus 10 upon 2. D is 10 to power minus 4. This is in radians, so for degrees this should be multiplied by 180 by pi. Okay, so this is 3 2s are 6, 30. So this is 5460 into 3 into 10 to power minus 5. Okay, so this is roughly 3 5s are 15. So this is 15,000 something there is 15,000 something into 10 to power minus 5, so roughly 0.16 degrees. So D is the correct option. Two identical radiators have a separation of this, where lambda is this, the initial phase difference between them is this, then the intensity on the screen at a distant point situated at an angle of 30 degree from the radiators. So this language is ambiguous. Complete situation अच्छी तरह से डिस्क्राइब नहीं है, स्क्रीन कहाँ पर है, किस तरह से प्लेस्ड है, कुछ भी अच्छी तरह से डिस्क्राइब नहीं है. आई वुड से दैट लीव दिस क्वेश्चन, दिस इज इनकम्प्लीट क्वेश्चन. यदि हम लोग इसको YDSE सेटअप की तरह इंटरप्रेट करें तो ये हमारे S1 और S2 दो सोर्सेज हैं और स्क्रीन फार अवे रखी हुई है एंड position 30 degree, you mean this position 30 degree. Okay, so path difference between the two sources will be D sine 30 degree, so that is lambda by 8. Now we are not given whether S1 is ahead of S2 or S2 is ahead of S1. So how to incorporate initial phase difference pi by 4, that is also not given correctly, whether S1 is ahead of S2 or S2 is ahead of S1. So let's take that S1 is ahead of S2. Okay, so overall phase difference will be initial phase difference pi by 4 plus phase difference due to the part difference 2 pi by lambda into lambda by 8. So this is pi by 2. It could have been 0 as well. Phase difference could have been 0 as well if S2 was initially in phase ahead with respect to S1. So that in that case pi by 4 minus pi by 4 would have been 0. So let's take S1 is ahead of S2. So now the intensity will be I is 4 I naught cos square phi, which is pi by 2 by 2. So that is 2 I naught. Answer could have been 4 I naught as well. I would say this is an incomplete question. A pipe of length L closed at one end is filled with gas and resonates in its fundamental mode with a tuning fork. Another open organ pipe of the same length. So for first pipe, F is V1 by 4L, and for second pipe, it is open organ pipe, again fundamental mode, so V2 upon 2L. So V1 is twice of V2. V2 is given 360, so 2 into 360, that is 720 meters per second. So this is at temperature 30 degree C. Now we have to calculate speed at 0 degree C. So V1 dash upon V1 is under root T dash upon T, that is 273 upon 303. So that is 273 upon 273 plus 30 under root, that is 1 plus 30 by 273 raised to power minus half, that is 1 minus 15 by 273 V1 dash by V1. Now 15 ones are, this is 1 by 18 roughly, so that is 17 by 18. So V1 dash is V1 into 17 by 18, that is roughly 340 meters. Sorry, 18 fours are 720. So 720. So that is roughly 680 meters per second. So closest option is 683 meters per second. The wavelength of two notes in the air are this and this. So we see that lambda 1 is less than lambda 2. So F1 is greater than F2. Now each note produces 10 beats per second with a third note of frequency. This means that F1 is greater than the third frequency and F2 is the lesser than the third frequency. So F1 minus F3 is 10 and F3 minus F2 is 10. So F1 minus F2 is 20. Okay, so V upon 36 by 195 minus V upon 36 by 193 is 20. Okay, so this is 2 upon 36 into V equals 20. So V is 360 meters per second. Next question. the system is released from rest. This is a difficult question, actually difficult question for NEET. The system is released from rest with both the springs in unstretched position. Mass of each block is this and force constant is this. Extension in horizontal spring. So if extension in horizontal spring is x naught, say, from natural length, extension in first spring is x naught, then this pulley will move down by x naught by 2. So extension in this spring will be x naught by 2. Now from free body diagram, here tension is T, here it is kx naught. So kx naught equals T. For the horizontal block, T equals kx naught. And here this is tension T, this is T, so this is 2T. So if we draw the free body diagram of block, tension 2T is acting upward and the lower spring exert force kx naught by 2 and mg is in downward direction. So 2T plus kx naught by 2 is equal to mg. So 2kx naught plus kx naught by 2 equals mg. So x naught is 2 mg by 5k. So 2 mg, m is 1. So 2 into 10 upon 5k, which is 50, that is 0.4 meter. So 0.4 is the correct option. So overall it was extremely difficult paper, है ना. फिर भी आप जो भी नए कॉन्सेप्ट सीख सकते हैं उन पे थोड़ा वर्क करिए. कल मिलते हैं.